Hello folks, this is the first year 13 lesson with me and Squirrel. I am a little sore in the mouth. I think I'm going to have big dental problems, so I'm not very cheery today, unfortunately. We'll do our best though. So today we're doing vectors. It's a year 13 topic and we've got to meet something new called the vector product. So we've got to be able to find this vector product between two vectors. We've got to understand various properties of vector products. We've got to be able to use the vector product to find perpendicular vectors, and what else? And we've got to be able to find the equation of a line using vector products. So, any more to say on that? Don't think so. Oh yes, if you've got your handout, I sent it along with this lesson on the email. You can print out the handout and fill in the blanks, otherwise you'll have to make full notes, your choice. Right, multiplying vectors. You will already have encountered one method of multiplying vectors, two vectors I should say, called the scalar. Scalar product. Oh God, cat. That ends up in a number, doesn't it? So that's also called the, you might have heard Carrie Ann call it the dot product, because it's got a dot between the two letters A and B. So it's A dot B equals the modulus of A, which is the length of A, times the length of B, cos theta, and theta is the angle which is between A and B. So you could work out A dot B using this part of the formula, or you could work out A dot B by doing that procedure. So if you remember that, if your vectors were 1, 2, 3, and let's say dot 4, 5, 6, then following this method that you've learnt last year, that would be 1 times 4 plus 2 times 5 plus 3 times 6 comes to 32. We can define another kind of product called the vector product, which is going to end up not in a number but in a vector. Let's put it off now. We can, oh, we've read that, right, so this is the way you define it. A cross B equals mod A mod B sine theta times this little n. So where theta again is the angle between the two vectors, and it's gone a bit funny, so the n is, that should be is, not just s, the n is what we call the unit vector. In other words, it has a length of 1, which is perpendicular to both vectors A and B. So it's got a length, n is a thing of a length, a vector of a length 1, which is perpendicular to A and B. The vector product formula results in a vector, that's why it's called it, and is often referred to as the, not dot, but, as we see, cross product. A cross B equals this form here, mod A mod B, sine of the angle theta, which is between them, times n, which is the unit vector perpendicular to A and B. So vector products using some familiar unit vectors, hopefully you remember these, I, j and k, they're both, all three have got length 1, I is in the x direction, j is in the y, and k is in the z. So if we got to do A cross B, and we're using the formula above to do it, so the mod of I, which is the length of I, which is 1, times the length of j, which is 1, times sine of the angle between them, now they're at 90 degrees to each other, times a vector here, which has got length 1 and it's perpendicular to both I and j. Ooh, what could that be? Well, it's k. That might not be a surprise. And if you work out that sum, oops, sorry, pause, telephone. Oh, hello, hope we're back in. Right, so 1 times 1 times 1 times k is in fact k, isn't it? So then, does this mean we have j times I is k as well? Answer to that is no. The cross product follows what we call the right hand rule. Notice this hand over here. On your right hand, align your thumb, index finger and middle finger so that they're roughly all at 90 degrees to one another. For product A cross B, point your index finger, that's the second one for A, your middle finger is B, and therefore your thumb ends up being A cross B. Try it at home. See how much fun that is. For B cross A though, the index finger and middle finger need to swap places. You really need to turn your hand upside down. This means your thumb will be pointing in the opposite direction, the new B cross A. So we'll have to write that thing there will be B cross A. So, it's also because it's pointing down, then we know that that's, if we were doing it, would be minus what it was before. So that's why if we've got A cross B here, that's equal to the minus of B cross A, because it's the opposite direction. So vector products are not commutative. That means you can't just switch them around and they're the same thing. If you switch them around, then it's the negative of the same thing. And that's why we've got I cross J is K, whereas J cross I is minus K. Can you think what would be J cross I? What's perpendicular to J and I? Sorry, cool. Hopefully you've got the answer by now. That will be I, vector I. And therefore K cross J will be minus I. K cross I will be J, and I cross K, will be minus J. Just using that little rule over there, we can see that things like I cross I, well, I cross I would equal the length of I, which is 1, times the length of I, which is 1, sine of the angle between them, because they're parallel, the angle is 0, times something that's perpendicular to them. Well, sine of 0 is 0, so L ends up being 0. So that's why anything that's parallel is just 0. Perpendicular vector is 0. 0, 0, 0 if it's 3D. Right, some key points. I know we've been using that formula to work out A cross B, but there is another way of working out A cross B, and that's that thing in the pink box up here. The formula you can go and remember if you wished, but it can also be seen from finding the determinant of a 3x3 matrix. Now, we've not covered this topic yet, and it will be the next topic that we do, but it's fairly straightforward, so let's have a go. So what it is you pick the one in that column, so it's I, open bracket, then you ignore that row and that column, in other words, that row and that column, and you do the determinant of the 4 things that are left in there. So that's A2B3 minus A3B2. Selector. and then it's minus the next term, so minus j. Then you take out that column and that row, you do determinant on what's left, so that's a1b3 minus a3b1. And then it is plus, I'll fit that on, k vector, and then you take out that column, that row, and we're left with these four here, which is a1b2 minus a2b1. And you can see if you wanted to write that as a vector, I is just your x thing, so that's a2b3 minus a3b2. The j is just your y, and if you take the minus through, then it ends up being a1b3. That's wrong, so it's silly me. a3b1 is the positive, we take out minus through, and minus a1b3. And the bottom one is a1b2 minus a2b1, which you can see is the same as that pink thing up at the top there. So, properties of vector product. We've seen this one before. A cross B is the same as minus B cross A. And this is scalar through. If K is a scalar, or just a number that is, KA cross B will be the same as K bracket A cross B. A cross B cross C is the same as A cross B cross C, as long as you're in the same order, no matter which one you do first. And A cross B plus C is actually the same as A cross B plus A cross C. This thing here, the vectors A and B are parallel, and A cross B is 0. That's like we showed you with I cross I is 0, because if they're parallel, then the angle between them is 0, and sine theta therefore will be 0, and the whole thing ends up at 0. In particular, A cross A is 0. Right, we'll use those properties in this example here, I think. Like part B anyway. This one says, evaluate the cross product by evaluating the determinant and verify it's perpendicular to both vectors. So if we do the determinant for these two vectors, if you're wondering what those two vectors are, they are 2 minus 2 minus 1 cross 1 minus 1 minus 1, and we set those up in the matrix. Yeah, there we are, set them up. Let's rub that silly line off. Set them up in the matrix like that, and then as before it's I, and then the determinant of those four, so that would be 2 take 1, and then plus j, take out that column, that row, so it's minus 2 plus 1, and then plus k. Oh, we made a mistake here, not there, put plus, naughty me, because it's plus I minus j plus k. I don't know. And then take out that column and that row, and then it's minus 2, take away minus 2, plus 2, isn't it? So the vector we've ended up with here will be 1. That makes minus 1, but it's a minus there, so it's actually, so that makes minus 1, yeah, which is minus, it's ended up with 1 again, and that's 0, isn't it? So that is the vector which is perpendicular to those two. And we can prove it with dot product, because we know if dot product equals 0, then two vectors are perpendicular. So if we did 2 minus 1 dot 1 1 0, dot product, remember, times the two together, 2, add those twos, that's minus 2, add 0, and it equals 0, so therefore perpendicular. And same with the other one, 1 minus 1 minus 1, that's this vector here. If you dot that with 1 1 0, you might agree, gives you 1 plus minus 1 plus 0, all equals 0, therefore again perpendicular. So we've done that one. Right, part B, we're going to use the laws to do this. Prove this is this. So we'll start with left-hand side. that times that, well, we can do 2a cross a plus, keeping this like expanding brackets, isn't it? 2a cross 3b, and then minus b cross a and minus b cross 3b. Underline all these things because they are vectors. Right, AA parallel 0. These 2 times 3 is 6. We've got 6 lots of A cross B. And this one, because minus B cross A can be the same as plus A cross B, can't it? Ooh. And this B times B, again, these are parallel, whatever size they are. So that ends up at minus or plus 0. So we're left with 6 of them and 1 of them, so that equals 7 A cross B. And that's what we were trying to show. Bingo, right hand side. Right, your turn. Have a go at this one. Evaluate the cross product by determining the Evaluate the cross product by evaluating the determinant and verify that they are perpendicular. So there it is written as a matrix, just like I did in part A of the last question. You have a go at that. If you can pause the video now and have a go. Okay, probably pressed unpause. So here is the answers. That was the vector we should have ended up with. That's the answer, the -1. If you can see what I'm talking about. That's the answer. Could be written as that or that. And that's verifying that they're perpendicular by dotting them together and you get 0, therefore perpendicular. Right angle. Shorthand. Okay, finding a perpendicular vector. Should we wish to find a vector that is perpendicular to 2 given vectors in 3D space, the vector product is rather useful. The cross product, or vector product, same thing, of the 2 vectors provides us with a vector that is perpendicular to both vectors. The proof of this can be seen in the homework extension. And I promise you, it's not as painful as this toothache. So example 2. We've had example 2 before, but anyway. Find a unit vector which is perpendicular to these 2. So this is 2 lines, equation of lines. You may remember seeing them as this: 2, 1, 0 plus lambda 1, 0, 2. That's probably the way you like to see them. That's the way I like to see them anyway. But they're given in IJK form. Remember component form. So using the direction vectors, we can find something that's perpendicular. So those 2 are the direction vectors, which you might prefer to see them as 1 minus 3. No, that's 1. That's not 1. 1 minus 3, 0 cross 1, 0, 2. So crossing them together, we'd write the IJK there, the 1 minus 3 naught, 1, 0, 2, and then perform the business. So it's I vector, that's -6, isn't it? Plus, did it again, minus j, not plus j. Minus in there. J, so you take out that column, that row, and you're left with 2, take nothing, so that's 2. And then plus k, and we've got, that's gone, that's gone. It's got 0, take 3, so that ends up as 3, doesn't it? So we have in fact got the vector -6, 2, 3. We want the unit vector now. That hasn't got a length of 1, and we need it to have a length of 1. So what we're going to have to do is find the modulus of that and then divide it by it, so it gives us the unit vector. So the modulus, squashing this on, of -6, 2, 3, bit of Pythagoras, square root. So that's 36 plus 4 plus 9, and that gives you 49, which square roots to 7. So our answer here will be 1 over 7 component form or vector column form minus 6, 2, 3. And there we go, done. Example 3. Find a unit vector which is perpendicular to the plane containing these three things. Right. So we've got this plane, we'll call these A, B, and C. Vectors in these two planes, we could have AB and AC, and we need to work those out. Remember how to do that. So that's B takes A, and that one C take A. If you do that, you'll end up with, so we're doing B take A, you get, and if you do that one, you end up with that. So the thing that's perpendicular to that will be the cross product of these two. They were written in component form, would look like that, or vector form ones we've just done. Set them up in the matrix thing, and then we have to work out the business. So that's I, and then it's that times that 4, add 2, take away J with minus 4, and that's 2, minus minus a plus 3, and then plus K, and in there we're going to get 2 plus 3. So that ends up giving us the vector 6, 1, and 5. So a unit vector would be 1 over the modulus of that lot. And if we were to do the modulus of that lot, 1 over root of, right, we've got 36, 37, and 25, haven't we? So 37 plus 25 makes 62. So it's square root 62, not a nice number. So we'll leave it like that. Have 6, 1, 5. Done. Say any questions, but not going to answer here, Mama. Sorry, grumpy today. Right, example 4. Use the vector product formula to find the sine of the angle between these two. Ooh. Right, that's our formula. And we're trying to find the sine of the angle between them. Right, let's jump to that. How's that? Well, we know that n, what is n? N is a unit vector, and it's perpendicular to A and B. So actually n is, in fact, A cross B over the modulus of A cross B, isn't it? That's what n is. Now, if we divide both sides by n, you'd end up with 1 over n times this, and it disappearing on that side. Now 1 over n will be the inversion of that, so that would be, that inverted would be A cross B over the A cross B, so the mod, that's 1 over n, because you're dividing both sides by n. And then you've got to just write out that line with the n gone on that one. You can see those two things will cancel each other out. So we're just left with this line here. And then that line, you can rearrange it to get sine theta. And then it's just a matter of working these things out with numbers. So that cross that, put it in matrix form. And then the answer will be I lots of 5, minus 5, in fact, minus 5. Then we've got plus, no we haven't, which is a silly little person, minus j, and then we've got minus 5 take 6, big numbers, plus k, gone, so just got 0 take 2. So what vector is that? Well, that's the vector minus 5, 11 and minus 2. Okay. So back over here, sine theta equals that vector. So minus 5, 11, minus 2 divided by the modulus of A times the modulus of B. Back to here, what's the modulus of that thing? That's 1 plus 1 plus 9. That's 10, isn't it? No, it's not. It's 11. And the modulus of this one, 4 plus 25 makes 29. And that basically is the answer. If you work it out, it's 0.686, I think. Shift sign it if you really want to find the angle, but it only said find the sine of the angle, so you leave your answer in the decimal. Right, you're thinking, oh, this is quite palaver. Yeah, you've got that fancy calculator and it can do vector products on it. Let's just run through these things and see how might be downstairs. I think I'll pause the video and go and find it. Right, okie doke. So what I've put here is you can also find the vector product on your calculator. Go to run mode. Yeah. Press F3. Yeah, that's right. Matrix and vectors. F6, because you've probably got matrices at the moment. So you press F6, they'll turn into vectors. Enter the 2 by 1 vector. So 2 by 1. The 3 by 1 vector. So just type in there 3 for M and 1 for N. And then you might get the vector pop up 0, 0, 0. Just change those numbers to be, in this case, 1, 1, 3. Press enter. I think you might have to press exit to get out there. Exit. And then hover down to vector B and do the same. Put a vector in, such as, what is it going to be? 2, 0, minus 5. Exit to get back onto that screen. Right, so then you've done that. So now press Option, OPTN button, and F2. That would delete everything. That'd be mad. Let's not do that. What did it say? Have I followed it properly? So enter the 2 3 by 1 matrices. Yes, we've done that. Then press exit. Press exit a couple of times. So you're back on the run mode screen, not vector screen. And then press F2, which is matrix vector. So really should be two exits there. I think for me it was another exit. I can't do exit with me mouse. Another exit, 2 exits there. And then press Option F2 where you see the matrix vector button. F6 for arrow. And then F6 arrow again. And then on F3 you should see cross product. So press that. It's quite palaverous, isn't it? Oops, my calculator's gone round. Right, so you press that. No, exit. Sure you'll be having fun here. So we've got cross product with a bracket open, and you'll have to enter vector, which is on F1, vec A, comma, which is above the del button, and then vec F1, alpha B, end the bracket, and press EXE. You see it's worked out that minus 5, 11, minus 2. Hopefully you've had fun with that one. Right, so you can use this calculator to do things like vector products. The only reason you wouldn't be doing the calculator to do it is when they put algebra in there, and believe me, they do put algebra in there, so you do have to be able to do it the hand-by-hand method with the matrixing. Right, vector equation of a line. Do you remember this? From what we know about the vector product, we can deduce a simple alternative. So what you've been used to, you used to do R equals A plus lambda. You might remember it as B minus A, or you might just call that another vector B sometimes. They call it A, R equals A plus lambda B, where B is B minus A, but those are the type of things you met last year. So an alternative to that, we know that the vector product of parallel vectors is, so we know that the vector product, that's the crossing of parallel vectors, is 0, don't we? I cross I is 0, A cross A is 0, etc. It follows that a suitable vector equation is that thing. Where have they got that thing from? You're probably wondering. Well, I don't know where they got that thing from. Let's see, we're normally used to this. So we have got, I think we'll pause the video, we'll have a second. Right, yeah, let's go back to that statement up here. We know that the vector product of parallel vectors is 0. So this vector here, this vector down there, and this vector are parallel, aren't they? Because that's the direction. So we know that A to R cross B will give us 0. Now, A to R can be described as R take A, can't it? Just like we've done with A, B and whatever, because to get from A to R, you go down the A, up the R. So that's known as R take A. And if you cross that with B, the direction, you get 0. And that's another equation of a line, but using the cross product. How fascinating. Right, there's our formula. It says here, the vector equation of the line. Find the vector equation of the line that passes through these 2 points. Okay. Right, any thoughts? Right, well, A is 3, 1 minus 2, and B is in the vector B when we talk about things like is the direction of the line going from A to B. So that is in fact the direction vector A to B. That'd be B take A. And if you do that little sum, you will get minus 3, minus 5, and 10. Lovely. Right, then we're back on this formula here. So R, we don't know what R is. R minus A. Cross it with this vector B. And the answer will be 0 vector. 0, 0, 0 if you want. Using the multiplying out law, we can say that times that. And then take away that. And then we can take this bit over there and use our calculator to find the cross product of those two. or you do it with the matrix thing. I'd use your calculator now, you know what to do. So you end up with r cross -3 -5 10 equals, and on your calculator you end up getting, I hope, 0, is it 0 -24 and minus, oh goodness me, no, -12. Let's just check that. So you'd have to go back in your calculator. Yeah, you're in run mode, but you have to press a few buttons. Exit, exit, exit. Back to those instructions. F3. Change your 3 by 1. What were they? We've got 3. Oh no. 3, 1, -2. Come out there. And the other vector we're playing with here is this one. So that's down there. We want in there -3, -5 and 10. Exit, exit, exit. If you've got cross product up from before, you just go back, highlight it and go over it again. And yes, it's 0, -24 and -12. Right, is that the end of the question? Yeah, that's fine. The equation, the vector equation of a line, and they often leave it like that rather than like that. So that's a general way of leaving it. A cross something equals something. So basically they've left it as this: R cross B equals A cross B. And that's just a rearranging of that thing. Okay. Oh, it's all under there. Your turn on the whiteboard. Can you do the same thing with those two vectors? See if you can follow it and leave your answer in the form AR cross B equals A cross B. It's just rearranging that. So pause the video now and give that a go. Right, you probably put it back on now. So your first vector, that's your vector B's are directions, that's CD, you work that out. Turns out to be that, and then you pop them in the formula and then twist them about, use your calculator on that last bit, and you should end up with what we've got on the bottom there. Super dupe. And the exercise to do is there. I think we said before doing the earlier bits of 5A, questions 1, 2 and 3, but it's going to be all of those questions and they'll be on your homework sheet anyway. I'll have to photocopy the sheet because and scan it in because you haven't got your textbooks yet, but I hope you have some fun with them. Right, it's enough from me for today. Hope you're all well and not got toothache because it's rotten. And hopefully see you again later in the week.